Hi, I am Sravan Kumar, having 7 years of teaching experience, of which since 4 years I have been teaching gate, electric circuits, control systems, and machine subject. Currently, I am pursuing my PhD from University College of Engineering, Usman University campus. My main objective as a faculty is to enable my students to achieve their academic goals and also encourage them to work hard and lay down path foundations for a bright and successful future of the students. I believe you should hire me as a faculty because I am someone who has immense passion for teaching and I am someone who can use creative methods of teaching. Based on my experience as a faculty, the knowledge I have of my subject, and also my ability to deliver results based on GATE syllabus, I feel you'll be very much satisfied with the results I produce if you choose to hire me. I am highly organized and able to plan my work and create lesson plans accordingly to deliver consistently high standard of teaching. I have an extensive and in-depth knowledge of my subject matter, which means my students can get to learn more from it. I also have excellent written and verbal communication skills, and I would like to consider myself to be highly effective presenter who has an understanding of how to deliver complex lessons that would otherwise be difficult for students to understand. Finally, I have strong work ethics, am adaptable and flexible approach to teaching, and also ability to build strong professional relationships. Now I would like to discuss about Thevenin's theorem. So basically it's a part of electric circuits. It's one of the topic in electric circuits, Thevenin's theorem. This is common to both electrical and ECE students. On an average, you can expect 10 to 12 marks from this subject. So today I'll be dealing with what is called Thevenin's theorem. Now let's see what is Thevenin's theorem first. A linear and bilateral terminal network can be replaced by a linear bidirectional two-terminal network can be replaced by an equivalent network consisting of voltage source connected in series with a resistance. This is an equivalent voltage source, which is also called as open circuit voltage at the terminals or Thevenin's voltage. RTH, it is the input equivalent resistance at the terminals when the independent sources are turned off. So this is a linear bidirectional network which is connected to some load. These elements are fixed here, and this load can be a variable one. So this can be replaced by a single voltage source in series with a single resistance. This is called RTH. This is called VTH. So VTH is Thevenin's voltage or open circuit voltage. It's also called as open circuit voltage or Thevenin's voltage. And RTH is equivalent resistance, or you can also call it as Thevenin's resistance. And there is a procedure to be followed while you are evaluating VTH and RTH. First, you need to find VTH, Thevenin's voltage. First, you need to remove the load, disconnect the load from the circuit and mark the terminals, load terminals. Find voltage or VTH, it's also called as VOC, across the load terminals. That is a procedure to find VTH. First, what we'll do, we'll remove the load, mark the terminals plus minus, and find the voltage, open circuit voltage, or also called as Thevenin's voltage. Then how to find RTH? To find RTH, first in the same, disconnect the load or remove the load from the circuit and turn off the sources. Nothing but if you turn off voltage source, make it equal to 0. Voltage 0 is a short circuit, and if you make current source is equal to 0, it's an open circuit. That means replace all the voltages by short circuit and currents by open circuit. To be specific, these sources are independent sources. Then find the resistance, equivalent resistance across the load terminals. This is a procedure that is followed. Now this is connected to load again, and you can determine the current flowing through that load or power absorbed by that load or voltage across the load. So this is one of the technique that is used. It's to find the various parameters or currents responses in the circuit, and it's also one of the network reduction techniques. Now let's look at a numerical. This is the given numerical. The question is that find current flowing through the load resistance. This is the load resistance. You need to find this current flowing through that. When when it is equal to 6 ohms and 16 ohms. That means load resistance value is 6 ohms. Load resistance value is 16 ohms. This is the first case and this is the second case. Now let us try to solve this by using Thevenin's theorem. Although it's not specified by using Thevenin's theorem, you can solve the circuit by using the Thevenin's theorem. Now what is the equivalent circuit? That you need to write first. What is the equivalent circuit? So Thevenin's voltage in series with the Thevenin's resistance, and this will be the load RL. Let's take 6 ohms in the first case. Same circuit, you need to take this, and let's take now the RL value is 16 ohms. These are the first and second cases. This is the first case, this is the second case. Now the resistance value here, this is called as RTH, this is called as VTH, this is here called as VTH, and here it is called as RTH. Now you need to first find, either in this case or in this case, you need to first find VTH value. What is the value of VTH? What is VTH? Remove this load and draw the circuit diagram once again. If you can remove that load, what is the circuit that becomes? It becomes something like this. This is 2 amperes. This is 1 ohms. This is the open circuit. Load is removed here, and you need to find open circuit voltage or Thevenin's voltage. If you observe, because this is an open circuit, the current flowing through this is 0. So the voltage here is nothing but VTH or Thevenin's or open circuit voltage. That means the voltage here is VTH. The given resistance is 4 here. This is 12 ohms. This is 32 volts. Now you can apply Kirchhoff's current law at this point. Let us call this as I1, I2 and I3. Let's take all the currents are leaving. You can write I1 plus I2 plus I3 is equal to 0. Let's call this voltage as VTH or VOC. VOC minus 32 by 4 plus VOC by 12 plus already this current, because this is open circuit, the whole current will try to flow through this. So it is minus 2 is equal to 0. If you evaluate this, you'll get VOC and VTH is equal to 30 volts. Similarly, you need to find RTH. What is RTH is equal to? It is the open circuit voltage. When the load is removed, it is a Thevenin's voltage when by measuring the resistance across the load terminals. In order to find this, let's take this. You need to make voltage source equal to 0. So short circuit this voltage source and take this resistance. This is the other resistance, and also this is, since this here you have a current source, this must be open circuit, and this is a voltage source, this must be a short circuit, and both are independent sources. So I'm making this as a short circuit here, and this is 4 ohms, this is 12 ohms, and this is an open circuit. There is a resistance. Now if you look at this RTH, here 12 and 4 are in parallel, so RTH will be 12 into 4 by 12 plus 4 plus 1 ohm is in series. If this is open, 1 ohm is in series, so this will give you 4 ohms. So what is the value of VTH here? 30 volts. What is this? 4 ohms. This is 6. Now you need to find current through this. So current I is equal to total voltage into same branch resistance by total resistance. This is voltage. You can find first voltage, which is total voltage into same branch resistance by the total resistance, that is 30 into 6 by 6 plus 4. Or you can also find this, then you can find the current, or you can also find I is equal to simply V by total resistance. V is 30 by R is 4 plus 6. So 30 by 10 will give me 3 amperes. So what is the current flowing through this? 3 amperes. Similarly, current flowing through this will be same. VTH is 30, and this is again 4 ohms that we have got here. So V I is equal to same. What is V? 30 by 4 plus 16. It is 30 by 20, 3 by 2 amps. Here you can find first the voltage, then this is 10. 30 by 10 into 6 is 18. Then you can find the current through this. I is equal to V, voltage is 18 by 6, that is 3 amperes. The same you have got here. You can find it directly, or you can also find it like this. Thank you.